Hey guys! Today we are going to be doing a quick calculus video on the integral test, and I'll show y'all a quick example, but yeah, let's go ahead and get started. Now, the integral test is used with improper integrals to determine whether a series converges to a constant or diverges all the way up to infinity. And the integral test states that you can use this test if the series is positive, continuous, and decreasing. If it doesn't meet all three of these criteria, you're throwing it out the window and choosing a different test. However, if it does, we say that if the integral of the series converges, then the series also converges. But if the integral diverges, the series also diverges. So I'm going to explain what I mean now to give y'all a visual, because I'm definitely a visual learner and it takes me some time to learn something just from an explanation. But first thing we need to do is make sure all three criteria can be met. And that'll be the first step in the integral tests. So I'm going ahead and writing down a problem with n equals 1. And then the upper bound is infinity, of course. And then 1 over n squared plus 1. This is our series. And you can go ahead and write this down if you want to try this for yourself. But the first thing we need to do is test if it is continuous. Now, we know that it has to be continuous because the denominator can never be 0, which means it's always going to be continuous because the denominator is always positive. So we're checking that one off on continuity, because with that plus 1 and that n squared, we're never going to be negative or equal to 0. So the next thing we need to test is whether this is positive. Now, as you can see, there are no negative signs here, and the n is always going to be positive because it is squared. So we can check off that positive one. And the last one is a little bit trickier and more time-consuming to test, but we have to see whether this is decreasing or not. In order to do that, we're going to go back to our first derivative test and see whether we end up with a positive or negative. So I'm going to take the first derivative of 1 over n squared plus 1. So we're going to go ahead and just do our quotient rule real quick. So n squared plus 1 squared in the denominator, and then I like to do low d high minus high d low, and so we have negative 1 times n squared plus 1 squared, like this. And as you can see, there's a negative right here, and then this is always going to be positive. So that means the whole thing is negative, and therefore from the first derivative test, we can see that this is decreasing and it meets all three criteria for the integral test. So now I'm going to go ahead and erase this, and we can go ahead and use the integral test. So the next step, now that we've determined that all three criteria are met, is we need to evaluate the integral. So let me go ahead and write this out in integral notation, because summation notation can get a little bit difficult to understand. So let me go ahead and do 1 over x squared plus 1 with upper bound infinity, lower bound 1. And we need to evaluate this integral. So we're going to start by putting a b in for infinity, like this. And then we're going to integrate this. Now, this isn't too hard to integrate. We just need to remember our arctangent identities right here. And all this is equal to is arctan. So let me just do arctan like this with our upper and lower bounds. So 1 to b. And then the next thing we're going to do is evaluate this integral and see whether we get a constant or we get infinity. And remember, according to the integral test, if we end up with a constant, that means we are going to have a series that converges. But if we end up with something that goes to infinity, that means our series diverges. And that's how we use the integral test. So right here we have inverse tangent from 1 to b, and let's go ahead and do that test real quick. So inverse tangent of infinity is just going to be equal to pi over 2. And so we have pi over 2 minus, we have to do inverse tangent of 1, which you should know is pi over 4. And pi over 2 minus pi over 4 is going to get us to pi over 4. Now, this is a constant, and like I said, if we get a constant as our answer, that means the integral converges, and the series therefore converges, and that means we've used the integral test to test for convergence, and we found that it converges to pi over 4. That's all. I hope this helped, and comment down below any questions or anything. Bye!